right, today we're going to be factoring polynomials, and we're going to be using greatest common factor. So what do they have in common that I can take out? And by taking out, I mean divide it. Okay? So we're going to first simplify. So see, these were already factored out. We took an A out. So now if I distribute, A times 3A is 3A squared. And A times 7 is 7A. Okay? They both have an A in common that I can take out. That's what we're going to do today. We're going to start from here, and we're going to go to here. So the second one, if I multiply everything by negative 2m, negative 2m times m squared is negative 2m to the third power, because there's 1 right there and 2 right there. When you multiply it, now I have 3 of them. Negative 2 times 6 is negative 12. I have an m right here. M times m is m squared. And then negative 2 times negative 1 is a positive 2, and it only has an m, so I can put an m there. That means all of these have an m, at least one m that I can take out, and all of these can be divided by negative 2. Okay, and the last one, when I distribute this, 5xy times x, now I have 2 x's, so really it's just 5x squared y. Okay, that's all you have to do, just count the x's and put the square right there. And then 5 times negative 2 is a negative 10. And then I have 2 y's, so it's going to be y squared and 1x. So x, y squared. Pause the video and ask questions if you didn't understand that, or just take a look at it and see exactly what happened when I was multiplying them. Okay, so factoring. What is factoring? What do we do when we factor something out? Right? Factoring is separating back into a product. So separating back into a product. Okay, so for instance, a while back we were factoring, we were doing 3 factorization. So if I say 6, factor that, that's 2 times 3, right? So we're looking at factors, things that you can factor out. So an example would be if I have 4a squared plus 8a. Okay, both of these have an a in common, so I can take out an a. And they also both, they have factors of 4, so I can take out a 4. Well, if I take out a 4 from here, and when I say take it out, I mean divide. 4 divided by 4 is 1. And if I take an a out of here, I have an a left. 8 divided by 4 is 2, positive 2. If I take out an a, then there's no a's left. And that's just an example. We're going to do more examples in just a little bit. But if the polynomial cannot be factored, that's called prime. So if you see that they don't have anything in common, you cannot take anything out, then we're just going to put that it's prime. And there's one problem on here that is prime, so I'm going to show you what that looks like. Okay? So here are some rules for finding greatest common factor. We're going to be looking at the coefficient first. So the numbers in the front, like 3 and 12, what do they have in common? 8 and 36. Those are coefficients. We're going to look at that first. And then we're going to be looking at the variables. Okay? So the letters, do they have a letter in common that I can take out? So we're going to start practicing, because I think the best way to understand what I'm doing is by looking at examples. Problem number 1. I'm looking at 3 and 12. What can both of them be divided by? So I'm going to look in my multiplication chart, and I'm looking for 3 and 12. So look for a line that has both 3 and 12. They have to be in the same line. That means 3 can be factored out of 3 and 12. So we're going to go ahead and factor 3 out of both of those. So once you found it, we can go ahead and divide them by 3. They both have a 3 in common, so we're going to divide these two by 3. That means I can take out a 3, and then what do they have left over? Now, I cannot take out any letters. It says, look at the variables too. I cannot take out any letters because only the 3 has the x. 12 doesn't have an x. So I cannot take out an x, so I'm going to have to leave it in there. So then I do 3 divided by 3 is how much? Let's go back and look at our table. These are the numbers that I'm going to be left with, 1 and 4. Because 3 divided by 3 is 1, 12 divided by 3 is 4. Those are the numbers that I'm going to be using. So right here, I'm going to be left with 1x plus 4, because those were my numbers that I found on the multiplication chart. Let's try another one. Let's try problem number 3. Okay? Let's look for 8 and 36 on the multiplication chart. So look at your table, the green table, and look for, what were the numbers? 8 and 36. Let's look for 8 and 36. Where do you see it? Here, 8 and 36. They're both on the same line, right? So my factor is 4. I can factor out a 4. I can take a 4 out, and I'm going to be left with a 2 and a 9. Okay? Because 8 divided by 4 is 2, and 36 divided by 4 is 9. Those are my numbers that are going to be left over. Let's go put them over here. So I can take out a 4. Do they have a letter in common? Are these the same? No, so I cannot take out a letter either. Just the number, 4. And again, 8 divided by 4 is 2m. And 36 divided by 4 is positive 9n. Okay? Finished. Let's do problem number 5. What do these two have in common? ¿Qué tienen en común? Ah, A, right? They both have an A. There's an A here, one A, and there's an A here. So I can take out an A. Take it out. One A from both of them. So if I take out an A here, what's left over? ¿Qué me sobra? B, right? And if I take out an A here, what's left over? Minus 1. It's an invisible 1. There's a 1 right here, right? Invisible 1. So when you take the A out, you're left with just a 1. That's it. These are my answers. This is my answer. This is my answer. This is my answer. I'm factoring out. Okay, let's go look for 5 and 13. 5 and 13. Look for it in the multiplication chart. 5 and 13. Where is it? Five and 13. Where are they? It's right here and right here. They're both on the same line. It's a 1, right? I can divide by 1. So let's go back. Do they have a letter in common? ¿Tienen letra en común? No, they don't have a letter in common. So I can only take out a 1. If you can only take out a 1, that's a prime number. Prime polynomial. You cannot take anything out. You cannot take anything out. Because if you divide by 1, you get the same thing. If I divide this by 1, you get 5. If I divide this by 1, I get negative 13. So it'll give you the same thing back. That's called prime. Okay, so from now on, if you can't find another number other than 1, then you're going to leave it as a prime number. All right, what about this one? Let's go look for 2, 2, and 4. 2, 2, and 4. Here, right? 2 and 4, and 2 can be divided by 2. So I'm left with 1 and 2. 2 divided by 2 is 1, 4 divided by 2 is 2. So that means I can take out a 2. What else can I take out? What do they have in common? ¿Qué tienen en común todos? An x, right? I can take out 1x from here, 1x from here, 1x from here. So I can take out an x. What else do they have in common? Y, right? This has a y, this has a y, this has a y. So I can take out a y. Perfect. What's left over? You start dividing and subtracting. So 2 divided by 2 is 1. If I take out an x from here, what do I have left over? Si le saco una x, ¿qué me queda? 1x, right? And if I take out a y, then I don't have a y left over. That's it. What about this one? Negative 2 divided by 2 is negative 1. If I take out an x, I don't have any more x. If I take out a y, here's 2 y's, right? And then I take out 1 y, then I have 1 y left over. What about this one? 4 divided by 2 is a positive 2. If I take out an x, I don't have any more. And if I take out a y, I don't have any more. So this is my final answer. Okay? I factored out 2x, y, and I was left with 1x minus 1y plus 2. Pause the video. I want you to try number 6 by yourself. Just try it for a little bit, and let's see if you get the correct answer. Pause the video now. Okay, you should have paused the video. You should have done this problem by yourself. We are looking for 35, 20, and 15 all on the same line. 35, 20, and 15. Did you find it? 35, 20, and 15. All on the same line. That means I can factor out a 5. Okay, and I will be left over with 3, 4, and 7. So, I'm going to take out a 5. What else do they have in common? They all have an A. Right? There's 2 here, there's 1 here, and there's 1 here. So I can also take out an A. Factor out an A, right? So if I divide 35 by 5, that's 7. If I take out an A, how many A's do I have left over? 1. Okay? Then negative 20 divided by 5, that's negative 4. If I take out an A, there's no more. If I take out, and then I don't have to take out B's, so I'm left with 2 B's right there. Because I didn't take any out. And then A right here, if I take it out, then I don't have an A left over. 15 divided by 5 is 3.